So I'm going to have to start from the Arduino is what we require. So we bring it out like this, then we place it there. We also require a digital input, this one. That's our digital input. We call it a button switch. If you press on it, it will indicate a 1. If you have not pressed on it, it will indicate a 0. So I want us to do one at a time, as in we start with the digital input, then we go to the digital output later. But I want us to read the value first, that value that you're going to use to affect this output based on a program to implement for us the NOT gate and the other gates. So, but we start with the NOT gate because it's just one button switch plus one LED as an output. So how do we read the input? Please note that you require a resistor, and that resistor you connect it to this section like this, so that you are going to connect it down. You use wires. The moment you click on any one of the terminals, you will see actually it becomes active. So just connect it down like this and join. So you click on the first active terminal, move, it will be like a wire, it moves to the next one. Then when you click on that, you release. That resistor can remain the same. Please note that you can change its resistance through this point, but we just leave it the same. You can have it as ohms, you can have it as kilo ohms or mega ohms, and you can change these values maybe like if you want 10, if you want 100, and you can see the value here is changing 100k and so on. But 1k is okay, or even 10k is fine. So you can see a resistor is usually important because here we are actually going to use it to drop a voltage so that it's able to give us an input. Remember I described these ports. They are digital inputs and outputs, and these are mainly analog inputs. And this is the power. So you're going to connect this terminal to one of the digital inputs. Just take a wire and connect it even to 2, and our 2 will actually be our digital input. Make sure you connect it that way, the same way I connected. You could connect your wire in any convenient way. This is my own way of doing it. So after you connect that, now we connect to power, and we can connect 5 volts. We connect 5 volts to 1A. Remember, the resistor was connected to 2A. Then the input to whatever we have connected to 2 digital input is a 2B. So this takes 1A. And you change the color. Please know that you can change your color from here to red because it's power. Then you can pick your ground from here because the resistor is supposed to connect us to ground like this. So the resistor connects us to ground just like that. that circuit is actually complete the way it is to make our digital input. And I can annotate it. If you want to write something on it, you click on the annotation, and then you can say here this is our A. You will have it as our input A. So you click on that, then it comes A. So that's our switch, button switch, which represents A. So you can say button switch. So anyway, we are going to have it as a button switch, but it represents input A. So you could even put it also to be our input A. Just have it that way, and of course this side will be the resistor. This is just a resistor that we have connected here. So maybe you can also call it resistor. The others are wires. Then this we can call it Arduino. Like that. And you have labeled your circuit. It's completely labeled and connected. And I hope everyone has connected in a similar way. Part. So in the programming part, you just click on the code. So we have we go to blocks. Okay, code blocks, then text, then continue. And you see our default code appears. This time, this is our digital. It's connected to 2 and it's an input. So you need to change pin mode 2 because that's what we have. And we have it as input. Like that. So we can even comment and say take port 2. So digital port 2 as the digital input. And then of course, remember always, because we are going to display a value, you also declare the serial monitor and you say serial dot begin. So you start it, initialize uh, the serial monitor because it will help you display what you are reading from the digital input. And remember we said 9600 is the communication rate. Then here we can just say initialize the serial monitor. So initialize the serial monitor, that's it. They are done. So we can as well remove this, all of this, because we want to put something different. We are reading the value from the input, and when you read it, please know that we are going to use int a, your data structures that you might have done if you have. I'm going to store it in a variable a, remember, and what we are storing here is a digital input that you are going to read from pin 2 or port 2. So how do you read? Remember we said when you are reading, this is a digital input, so we use digital read. So digital read in brackets, close, and we are reading from 2. So here we comment and say read this digital sensed value and store it in A, store in variable A. So digital sensed value and store it in variable A. That's what you have done. So after storing, you can print it. Serial dot print ln, or if you want to print first with a letter, you can say print. Of course, when you are putting characters, that's what you do. And here you are printing without a line. So then the next one will do a line, and that way it will print in one single line. And we say A is equals to, so it will print for us the value, of course, which will be a rating. So we say print the value in A. In serial monitor. So print value in A in serial monitor, and then the next one will print now the actual value. So which means we take A, and that's what you're going to print. Then ln, so that it comes within the same line, and we say here print. Actually, this is the one which will print the value in A. Print the value in A, but the first one prints the character. Print the character. The characters. A is equals to, you just assume both of them are characters. So characters A and equal in serial monitor, then print the value in A in serial monitor, and we'll be able to see it actually printing. So I expect in most cases you can put a delay so that it shows. In fact, sometimes you could even put let's put a space. This one you can't put just directly the way you do it elsewhere. So if you want a space, you just do serial.print, then you print nothing, and that gives you a space. So in fact, this one means print a space. Print a space. There could be maybe an easier way of doing it, but this is how it can work with it. So it becomes easier, though a bit analog, but it's okay. Then, of course, those are 3 lines, which are not necessary. In fact, you could decide to print only this one. You can remove this, you can remove this, so long as you know what you are printing. And then after we print, you can actually do a delay. And let's make our delay to be 1000. That means 1 second. So which means wait for 1 second. So wait for 1 second. So your code is done actually. The next thing you're supposed to do is to start simulation to see whether it's working. So you click on start simulation. Then some of you, I think, will experience errors. but let me see what I have here. A is equals to 0, A is equals to 0, A is equals to 0. Then I'll sort out the errors later. So A is equals to 0, you press on the button, it should change to 1. And you can see it changes to 1. Please make sure when you are pressing, you press and hold. Don't press and remove. So press and hold. When you release, it goes back to 0, like that. So introducing the LED, we need to make sure that we have stopped the simulation. So you stop the simulation. So you click on the code so that the code just disappears from the workspace, and you are left with devices. So you pick the LED, bring it, and we expect to put it close to 13 there, because I want us to connect it to 13 and ground. So we connect to 13 and ground. So but you need to make sure you're also going to involve a resistor. If you can connect it directly that way, and then the LED comes there, and you change the resistor value to 220 ohms. So that's how it will be able to display. Please know that when you're changing the resistance, you click here, put the value you want, go here, change it to ohms or kilo ohms, whichever you want, or mega ohms, or sometimes giga ohms. These milli ohms, micro ohms, nano ohms, pico ohms, so on. But we have most of the resistance will be in ohms most of the time, and kilo ohms. So after connecting the resistor and changing its resistance to 220, just note that the best resistor is 220. Reason, if you put a higher value, this will be very dim, the LED, so you might not be able to see what it will be displaying. Then you also connect it to ground like this, and you change the color to black like that. So you have gotten our digital input, and we have our digital output, and you have connected the circuit for the digital output. The device you have connected, you can see it has a ground, and then there is a resistor here. So the next thing to do is to click on the code, and now you introduce the LED onto the code, and you can control it. Basically, we are going to control it in terms of a NOT gate. In fact, here we can even annotate and say it's a NOT gate that you are coming up with. So NOT gate like that. So after you annotated correctly there, you introduce this 13. Please check, and we are doing it step by step so that you guys can understand, and that's why I started with only the button switch. For most of us who have not done this, it becomes easy for you. In fact, you have never come across, but those ones who have done this is just something very easy. You are now dealing with complex things, which is okay, but we need to take care of the others who are getting it step by step. So how do we introduce? We look at, we have connected to pin 13. So introduce pin 13 here. Of course, after the input or before or whatever. Then we say pin mode, because it's an output this time. We do into brackets, and then we say 13 output. Make sure the syntax is such that this output is caps, then M is also caps. And then we say we take port declare port 13 as digital output, like that. So after declaring it, we use it here. This is where we are going to apply it. How do you know where we're going to apply it? You read the value, then you use it. Don't put it before you read. So we actually, then also we put it before the delay so that this happens before it delays. But sometimes it will depend on what you want to implement. So the best way is just have it after you read the value, then now you use it. And how do we use it? The pseudocode that we did can actually apply. So there are two ways that you can do it, and one way is to use the if statement. And if you are using the if statement, you said it's if a is equals to 0, digital write. Now, instead of you guys saying f is equals to, this time we do digital write because we want to affect the output that way. So digital write 13 high, because when you get a low, we are supposed to output a high. When you get a high, we are supposed to output a low. And then here you say s digital write 13 low. If you have used to, because some of you might be used to putting brackets, the brass brackets, you can put one here, you close, you put one here, you close, so that it works okay. For you, please, maybe you need to get used to, because that way, when you have many instructions, you make sure that you remember to put them based on the requirements. So just put them. It will be okay. And then the delay will be on its own, which means it will be able to delay for us the 1000, that's 1 second, or 1000 milliseconds. So that's when you're using the if statement. So when you're done, you go to start simulation. Then we see what happens. And you can see our LED is automatically on because A is actually 0. So if I press on the button switch, which is the push button, then it's actually supposed to go off. You see it goes off. Why? Because our input here is 1, and our button switch is pressed. So I've actually pressed continuously. Yeah? That's why it's behaving that way. Even if I'm moving a mouse, my cursor is pressed. That's why it's actually giving us that. So even if I release it, then of course that will go off, and this should change to 0. What happened? Anyway, it just pressed continuously that way. So, but that's how it works. This one, and that's when you are using the if statement to be able to do your code. So if I don't want to use the if statement, I will just remove the if statements, all of them. And what do I do after removing the if statement? I do digital write 13 A, not A but A bar. And please know that A bar, you first of all put the exclamation mark, then you put A. That's how you implement A in programming. I mean, not get in programming, sorry. Not get is implemented by using the exclamation mark, then it's followed by the variable. You will have negated or inverted. let's try to see whether it will give us the same result. Yeah. So, and you realize it's actually on when A is 0. So if I press on the button, it goes off, and A is basically 1. You can see that. So if I release, it basically goes back to 0, and we have actually done a NOT gate. That's how you implement a NOT gate with a button switch, and you have this one as an LED, which is an output. So the button switch is the digital input, the LED is the digital output. You can also annotate it and indicate here LED. This is our output F, so it represents F. There is a way I can implement this in software completely. I can eliminate the whole of this hardware and I leave only the Arduino, and it will work as a NOT gate. How do we do that? Just instead of digital write, use serial.print. So you'll say here serial.print, you print the two of them, but this time now you're printing F. So I'll print it this way. Then I will put here F instead of A. So I put F, and then here I put F. Yeah, because I'm going to print F and A, the relation. Oh, this one will be A bar. So you print A bar. So we have the exclamation mark and then A. In fact, this will print for you A, and then it prints for you F. And your space, you can remove the space from here and put it down here. And this will be a program which is done a NOT gate implemented in software form. Can you see that? Oh, but now the digital input. The input is not, in fact, the output is what you implemented in software. The input is still hardware. Can you see that? The input is still hardware. If you want a software input, we eliminate it. This is what you do. Instead of doing int A, read A into that, you do random. So you randomize the values, and you're going to have 0 and 1 only. Yeah. So this is F, and this F, and then of course random. It will store a random value of 0 or 1, and we'll be able to see that when you run. Which means I've now eliminated this digital input using a random input. But sometimes you can also input a value, just like you do in other programming languages. Let's see what happens. If A is 1, F is 0. If A is 1, F is 0. If A is 0, F is 1. So it interchanges. It actually interchanges them. Yeah, you can see that very clearly. And you have done the implementation. In fact, in this circuit, if now I were to remove this, I remove this, but I need to be left with this one because it's the computer now. Then I will be able to get everything implemented in software. So, and this is what happens out here now. And that's why we are learning computer organization. I'm showing you on how the hardware works. I'm also showing you on how the software works also. Inside the computer is basically software. But when you come outside the computer, like the keys we are pressing on, they are these ones. Please note that the keys that you have on the keyboard, they are these ones. Then the output will be the what? The display. The display, the whole of this display we have here. Yeah. So I'm modeling this large computer that we have here that we are using to using a small computer, which is an Arduino. And that way we're able to learn and see what happens inside the computer in actual sense. That's my objective usually, and I hope most of you are getting it in terms of computer organization and architecture. To me, it works very well because I think it explains these concepts in relation to computer science. Because there is software, you are seeing it, you are seeing how we are changing the hardware, we see the hardware itself, then we see on how to change it. And I think we'll plan, maybe we see on how some of you will get some of these components at